Least cost combination of inputs are problems for the factor market unit where we are trying to fill an order using the least cost combination of two variable inputs such as labor and capital. So imagine your business gets an order for a specific amount of units of your product. In the business of maximizing profits, you want to fill that order with the least cost combinations of inputs, let's say like labor and capital, but they can be any inputs, land, entrepreneurship. The idea here is that you're going to lower the total cost or try to make it with the least cost, so therefore your profit is going to increase using the least cost combinations that I'm just kind of guessing, so it's much more mathematical. So you can hire as many workers or capital to make your products as you need to fill the order. This differs from profit maximization problems where you're just simply hiring as many units of inputs as are profitable. In this case, you have an order and that's what starts up front. So given this problem, you receive an order for 320 units. Each unit of labor costs $10 to hire, and each unit of capital costs $20 to hire. I'm going to make note of that, $10, $20. What is the least cost combination of labor and capital to fill this order? So here is my labor side, and here is my capital side. So I know that it's going to cost me $20 to hire capital and $10 to hire labor. Now they've given me the marginal products for each one, and if they gave me total product, I would just need to calculate marginal as the change in total product. And then what I'm going to have to solve is, well, what's the marginal product per dollar of each unit of labor and capital? So as I go through, I'm just simply dividing, the marginal product divided by the price, 10. So this is going to be 4.5, that's the cost. 40 divided by 10 is 4. 3.5, 3, and 2. So what I'm simply doing again is just the marginal product divided by the cost or the price of the input. So when it's dividing by 10, I'm just moving the decimal, and over on the capital side, we're dividing by 20 to get marginal product per dollar that it costs. So 60 divided by 20 is 3. Then we have 2.5, 2, 1.5, and 1. So now I'm looking to fill the order of 320 units. So I'm looking, much like the marginal utility per dollar problems of utility maximization, what I'm looking for is the most or the more marginal products per dollar. So now I'm going to kind of go step by step. So when I'm looking at the first unit of labor, gives me 4.5 marginal products per dollar, whereas the first unit of capital only gives me 3. So the first decision I make is to produce or hire the first unit of labor, which is going to give me 45 products, and I'm going to keep track of my total products until I filled my order of 320 units. So then I'm looking at the second unit of labor, 4, versus the first unit of capital. You can't look sideways 2 and 2 because you haven't yet hired the first unit of capital. Now it turns out I hired the second unit of labor because 4 is still greater than 3 of the first unit of capital. So now my total is not 45, I'm at 85 units. Still need to keep hiring to get to that 320. Then if you notice, 3.5 is greater than 3, still kind of looking there. And so now I add 35 units to the mix. So that gives me 120. Now if you notice, the fourth unit of labor and the first unit of capital are equal. So I'm going to hire both since I still need them. So I'm going to hire the fourth unit of labor and the first unit of capital, which is going to add 90 to my mix, so that's 210. Then, looking at 2 versus 2.5, I'm going to take the second unit of capital now, and that's going to add 50, so that gets me to 260, getting close to my 320. Then, both are 2 again, and if you notice, I need 60 more units left, so 320 units gets me to my order number. So the answer to the problem would be that I would hire 5 units of labor and 3 units of capital to fill the order of 320 units using the least cost combination of inputs.